Jai Hind all of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering. So today one of the another complex topic that I am going to discuss is support vector machine, right? So you all know that we have already discussed that there are different types of machine learning techniques, right? Which are supervised, unsupervised and reinforcement learning, right? So this support vector machine comes under supervised learning. In previous lecture, I have discussed about all these types of learning. Now, today I'm just going to brief you about the introduction, its introduction of support vector machine, SVM, that we called SVM. Kernels means functions that we going to use in this SVM. Types of kernels, its types, I'm going to discuss about its types, and what are the advantages and disadvantages of SVM, that I can say that pros and cons I will discuss today, and lastly the applications of SVM that I am going to discuss today. Okay, so first of all I must introduce you with this SVM. What is SVM? See, so with this under this supervised learning, this SVM comes, support vector machine. So supervised learning is a learning technique, machine learning technique, and support vector machine is a supervised learning technique, and basically it is used for classification and regression problems, where we need to classify the two classes. Multiple sets were given and we need to classify ki under what category those sets, yeah, those quantities, those real entities we will use to categorize the data here. That is called classification and regression problems. So basically used for SVM, used for classification and regression problem. See, okay? And most of the times we will use SVM for the classification problems, right? So support vector machine is highly preferred by many of us for its accuracy and less computation power. So actually this SVM is it is a discriminative classifier, what I can to discriminate, to differentiate, okay, and it is basically used for its accuracy and less computation power. So these you have to need to remind these 2 points: accuracy number 1 and number 2 is computation power. So for this we will use support vector machine. Okay, so as I have already said ki SVM is a discriminative classifier. Discriminative classifier means we will use to define the plane, different planes, and at either side of the plane we will use to classify the different sets of problem. Okay, that it is defined by separating the hyperplane, that is called as hyperplane here. Okay, so in other words, if I want to explain you that some labeled training data is given, labeled training data, labeled means supervised learning, because we know that in supervised learning teacher is present, we know the input, we know the output, and we need to train the machine on some machine learning algorithm, and that data is that algorithm will predict, right? So this can be explained as labeled training data. If I am talking about labeled training data, then supervised learning, because in supervised learning we are already given with input and output. It means data is labeled, the algorithm output, what algorithm will output? It will output an optimal hyperplane. Hyperplane means that hyperplane is defined and that plane is used to categorize our examples, which categorize the new examples. Okay, so how I can define this hyperplane? This hyperplane can be defined as a 2-dimensional plane, 2D plane, like this. For example, I will define it like this 2D plane, and some sets of the data points are here, and this is a one class and another class is circle, it lie at other side of the plane. So this is the classification. So this SVM helps us to do this. Okay, so same I have written here, it is a 2D dimensional space, and this is a line dividing a plane into 2 parts, and in each class lies in either side. For example, this is my class 1 and this is my class 2, and this is my straight line. One class lies above and one class lies below this line, right? So this can be represented like this. I have just shown you. So this is a hyperplane, okay, and we just need to define this plane. I just in coming slide I will define you what is the margin here, how we are going to categorize these two classes. One is rectangular class, one is circular class. ठीक है, तो actually what happened, you all know that in machine learning algorithm we just give the input, है ना, then model training, after training that model it will do some prediction, ठीक है, on the basis of some new data. So this new classes will be given here, new data will be given here. What are the new classes? For example, rectangle या square and the circle class is given, that new data is given, and that will be predicted and we will get an output. What is the output? Output is at the one side circle will lie and the another side this square will be lie. This is the classification in the same manner. Okay, these are more examples here. That hyperplane can be some like this also, that hyperplane can be here also, that hyperplane can be this also, ठीक है ना, right? So it depends here. So what is the objective here? The objective of the support vector machine algorithm is just to find the hyperplane in an n-dimensional space, right? The value of n can be n number, n is equal to 2 dimensional, 2D, 3D, 4D, n number of planes can be defined, है ना? And what are the purpose of this plane? The purpose is just so that we can distinctly classify the data points. So this is the main objective, है ना? Keep in mind, right? So support vector machine, the objective is to find a hyperplane, ठीक है? Where we are going to find the hyperplane? In an n-dimensional space, है ना? And what is the purpose of that n-dimensional space? The purpose is so that we can distinctly classify the data points as already defined in the previous figure, right? Like this, or it may be like this. Yes, okay, it may be like this. So we just need to find this hyperplane, okay, like this. See, so there are a number of hyperplanes, but now the question comes that which hyperplane we are going to choose. So we will going to choose this hyperplane, see, which will classify, linearly distribute the classes, okay. So to separate the two classes of data points, there are many possible hyperplanes. For example, you can see in this figure there are many possible hyperplanes. There are number of hyperplanes, and the question is that, what is the question? Question is that which hyperplane I have to choose, because I have already explained you that the objective of SPM is to choose the hyperplane, right? So what is our objective? Our objective is to find a plane that has the maximum margin. We have to keep in mind. So keeping in mind this maximum margin, we have to find that hyperplane. What is the meaning of this maximum margin? This means that maximum distance between the data points of both the classes, as I have shown in the previous figure. This is the, see, so this is the hyperplane, right? And from this hyperplane, this class, the distance between this class is maximum from both the sides. Distance between the both the classes is same. So this is a maximal margin. This is called maximal margin, right? Same here. So this is the, see, maximum margin. This is my optimal hyperplane. This is the maximum margin. Okay. So maximum margin means maximum distance between data points of both the classes. Okay. So what we need to do, we just need to maximizing the margin distance, and for that we have to implement some techniques, some sort of reinforcement. ठीक है. Reinforcement means so that future data points can be classified with more confidence. ठीक है. As you all know that we have already discussed this reinforcement learning where the system of rewards come into existence. What is the concept of reward there? Reward means, for example, if somebody prepare for the examination without the presence of the teacher, so he or she used to study herself or himself. So for example, first time he or she fails, so what is that failure? Failure is the output, that is a reward. So what happens next time? Next time that student will do more work hard, है ना? And what is the consequence of that work hard? Next time the reward is pass. So that pass and fail is a reward. So on the basis of that reward, that student is an agent, that he or she will learn from the environment कि how to update, how to get the optimal output. ठीक है. So on the basis of that reinforcement, some future data points can be classified, and with the help of this classification, how this classification is done? With more confidence it is done. Okay. So generally in books, in text, that SVM is described as a discriminative classifier. So now I think you will understand this term. What is the meaning of discriminative? Okay, we will use to classify the number of classes here, use to discriminate them, differentiate them. Okay, and this is a supervised learning algorithm, है ना? And we will get the hyperplane here. What type of hyperplane? We will get an optimal hyperplane, है ना? Which categorizes the new examples, new sets we will given here, right? So this is SVM. Okay, so now for example, you need to understand how these classes are classified. So there are some classes can be easily classified and some are very difficult to classify, right? For example, if I give you example, this is an example here, linearly separable data, है ना? You all take the example of, you have all studied that and or gate, है ना? The truth table of and or, right? And you know that what is the truth table of and? 0 0 0, 0 1 will output 0, 1 0 will output 0, and 1 1 will output 1. This is the truth table of and, है ना? And what is the truth table of or? This is of and what is of or? Or will output 0 1 1 1, right? So for example, when I used to explain this and or truth tables, I will represent it graphically. Then this problem, and or problems, can be classified linearly. Can be classified linearly, because if I explain on the basis of the plane, then what happened? Either side 0 will lie and another side 1 will lie. So I can just draw a hyperplane. Okay. So I can say that this and or problem can be classified linearly. Can be classified linearly. Okay. Now comes the non-linear. If you consider the XOR, if I consider the XOR truth table, what is the output of this XOR truth table? Whenever we get a different input, the output is 1. Okay. 0 0 0, 0 1 1, 1 0 1, 1 1 0. So this XOR problem cannot be separated linearly. Okay. Cannot be separated linearly. Once here lie the 1 0 1 1 0. So we cannot separate it linearly. Classification is difficult here. है ना? That I have in my previous lecture I showed you how we can solve this non-linear separable problems. These non-linear separable problems can be implemented using, can be solved using multi-layer perceptron model, multi-layer neural network. We can solve this XOR problem, है ना? And simple neural network, with the help of simple neural network, we can solve these problems also. Okay. So, but we are discussing about SVM. So I just want to brief you about the concept of linearly separable. Linear matlab the data can be linearly distributed. We have one hyperplane. Okay. So at above there is a dark circle and below that line lies the square. Okay. So what is this line? A line draws between these data points. Classify the black dots and blue squares. Easily classify. So I can say that this is linearly separable data, right? And next, non-linear separable, which cannot be linearly distributed. Both sides these stars are lying, and I do not find a line here which can separate this data, linear data. Okay. Now here the hyperplane is 2D plane drawn parallel to x-axis, that is the separator. So this is a separator I have just chosen here. Okay. But at either side in this 2D plane I am not able to separate this data. So this can be classified as non-linearly separable data. Okay. So now what is margin here? Margin, as I have showed in the before diagram, margin, yes. See, I have showed here, this is the margin. This is the margin. So how we can define this margin? So margin can be defined as a line, straight line, है ना, a perpendicular distance between the closest data point and the hyperplane. That perpendicular distance is defined as a margin here. And what is a hyperplane? You know that hyperplane is the best optimal line with the chances of that maximum margin, है ना, and we call it that margin can be called as margin maximal hyperplane. Okay? And the closest point where the margin distance is calculated are considered as support vector. Here the name comes support vector. Why we called this technique as a support vector machine? Because the closest point where the margin distance is calculated, from where we are going to calculate the margin distance, that margin distance is called as the support vector. Okay. So here so we call this learning technique, this is support vector machine. Okay. Because we need to find the maximum margin. See, diagrammatically you can see, this is a linear separable, this is a plane. I have defined this plane as a maximum margin decision hyperplane. Decision means this is the line from where I can easily classify these two sets. Okay. So what are the closest point? I have said you the closest points where the margin distance is calculated. What are the closest point in this figure? This is the closest point. See, this is the line, this is the margin where these classification, these data sets lies, है ना, here lying. So what is this? This is the margin, maximum margin is there. Okay. So these are the closest point. So we can call these, what we call it? It is called as a support vector. Okay. So in the figure also, the closest points where the margin distance is calculated. So from where the margin distance is calculated? From the support vector. So this is the support vector. These are the closest point, right? Understand? And we are going to define this with the help of this learning technique. We are going to find this margin. Okay. Now next, one important concept is kernels. Okay. So what are kernels? Kernels are the mathematical functions. Basically, what is the use of this function? We are going to calculate something. Okay, na? We will just going to provide some data and we are going to calculate. So kernels are the mathematical function for transforming the data. Okay. So using some linear algebra concept, we will going to use the kernels. Okay. So different support vector machine algorithms are used for these kernel functions, right? So these are the different types of kernel function. For example, linear kernel function, non-linear kernel function, Gaussian kernel function, polynomial kernel function, radial basis function, sigmoid functions. So these are the different SVM algorithm uses these different functions. है ना? What are those functions? Functions बोले तो mathematical functions. So definitely these functions are going to give us some mathematical equation. So on the basis of that equation, we are going to calculate the value. So different support vector machine algorithms were going to use these functions. So these kernel play a very important role in finding out the values of that hyperplane, right? So number one, for example, kernel function, it is defined as a function k of xy, है ना? How it is defined? It defined as a dot product of n dimensional input, fx dot fy, n dimensional fx and fy. These are 2 dimension. So this, on the basis of that, we will define the kernel function, right? So as I have told you, linear function, linear means simple function. So this is a function k x comma xi. So it is defined as, the formula for this is sum of x asterisk xi. So from the above formula we can see that the product between 2 vector, what are the 2 vector, x and xi, these are the 2 vector. What are the product? Is the sum of the multiplication. We are going to sum of multiplication of each pair of input values. So this is a simple linear kernel, right? Polynomial kernel behaves like basis on this function, right? K of xi comma xz, 2 input. So xi dot xj plus 1 whole d. Okay, so this polynomial kernel function is very popular for image processing, right? Now second, the Gaussian kernel. Again, the Gaussian kernel is x comma y. This function is defined as exponential of minus x minus y mod square upon 2 sigma square. Okay, na? So basically this Gaussian kernel is used when prior information is not given, prior knowledge about the data is not known. There is no prior knowledge of the data, then we will use this kernel function. Okay. Then radial basis function, RBF, that we called Gaussian radial basis function. It is a general purpose kernel. Okay, na? Again, when there is no prior knowledge about the data, we also going to use this Gaussian radial basis function. That function is defined as x I comma xz, 2 input, exponential of minus gamma modulus xi minus xz ka whole square, where this gamma is greater than or equal to 0, greater than 0. Sometimes this parameterized value is used for this gamma, 1 upon 2 sigma square. So this is Gaussian radial basis function. Fourth, Laplace. First is Gaussian radial basis function, Laplace radial basis function, okay, which will define on this equation. Okay, this is used to map input space in indefinite dimensional space, x comma y exponential of minus of modulus x minus y upon sigma. Okay, hyperbolic tangent kernel is defined as this equation. Okay, this is used in neural network, xi comma xz tan h xi dot xj plus c. Okay, where k is greater than or equal to 0 and c is less than or equal to 0. This is k. This is k. K is greater than or equal to 0 and c is a constant that must be less than or equal to, less than 0. Right? This is hyperbolic tangent kernel. This hyperbolic tangent kernel is used in neural network most of the times. Okay. Now, after discussing this, we should know some advantages and disadvantages of using this support vector machine. So I have defined here, make a list of pros and cons here. Okay. Pros means it really works well with clear margin of separation, as we have showed in lot of the diagrams before. If the margin is clear, then it will works very well. If the margin is not clear, then there is a chances of confusion also. Okay. Number one, it works really well with clear margin of separation. Okay. It is effective in high dimensional space. As we defined, it is defined, we are going to define the hyperplane and dimensional plane. So it is effective for high dimensional space, right? Third is, it is effective in cases where number of dimension is greater than the number of samples. As we know that both training data and testing data is given. So firstly, what we will do, we just use to train the algorithm. After training, then we will test that algorithm. So on the basis of that, this SVM is effective in cases where dimension is greater than the number of samples, right? Number 4, it uses a subset of training points in the decision function. What is a decision function? Decision function is called as support vector. so it is memory efficient, right? As I have defined that closest distance, that on that margin the closest distance is called a support vector na, so it will use a subset of training points. So from those training points the decision function is decided. So these are the advantages of support vector machine. Some disadvantages may be where it cannot perform well whenever we will provide a large data. If you provide a large data, then there are the chances that this SVM will not perform well. Okay? Because if the data is large, it means we are going to, the training time is very higher. If the training time is very higher, then there are the chances that SVM will not perform well. Okay? So when the training data is very large, we used to prefer neural network, ANN, artificial neural network. Okay? SVM is not preferred for larger data. Okay? So this is the one disadvantage, right? Secondly, it does not perform well when the data has more noise, more disturbance. More noise means some attributes are missing. More noise means we have multiple values. Okay? There are the chances that SVM will not perform well. Second, okay? Third disadvantage is that SVM does not directly provide probability estimates. It does not provide probability estimate. Means if some attribute is missing, we cannot estimate. Okay? For that Bayesian classification is best preferred for that. Okay? These are calculated using expensive 5-fold cross validation. These are the techniques. So it is very expensive. So support vector, this SVC method of Python's scikit-learn library. So we need to use this, which is very expensive. 5-fold cross validation. This is very expensive. So it doesn't provide probability estimate. So this is the disadvantage. Okay? Although for if the data is for fast accuracy and for fast output, we used to prefer SVM. Okay. Now some applications that we will use support vector machine is used in face detection. Nowadays, we need to fastly access the face. Okay. Second is text and hypertext categorization. In image processing also, classification of images, we can use SVM. Bioinformatics, we can use support vector machine. Handwriting recognition, lot of the applications we need a faster output, efficient output. For that, in handwriting recognition, we can use this algorithm support vector machine, right? And sixth is protein fold and remote homology detection, that is connected with this bioinformatics in medical field also. And lastly, generalized predictive control, right? As I have said that this is a classification used to solve a lot of the classification problems. So it is used to generally predict that control, predictive control, most of the classifications in industrial, in medical field, in space, weather forecasting also, we can use this SVM also. Okay? So these are the applications, and that's all from my side today.